Alright everyone, welcome back to Philosophy 1600, Logic and Moral Reasoning. This is week 4 review video. This week, we introduced the symbolic notation system that we'll be using for the rest of the semester. Before we get into the details of the notation system, I would first like to make a bit more precise what we'll be studying with this notation system. Okay, let's get started. Okay, let's go back to the basic. Recall that the subject matter of logic is entailment. Given an argument, we say that the premises entail the conclusion when the conclusion must be true, under the assumption that the premises are all true. Otherwise, the premises do not entail the conclusion. Equivalently, we say that the argument is valid in the former case, namely, when the premises entail the conclusion. Otherwise, the argument is invalid. Okay. Now, consider this argument. Premise: lions are mammals. Conclusion, therefore, lions are animals. We all know that every mammal is an animal. So it seems that the conclusion must be true if the premise is true. So, from the definition that we have, the argument is valid. Or equivalently, the premise entails the conclusion. Now compare the previous argument with this one. Premise 1: if Socrates is a human being, then he is mortal. Premise 2: Socrates is a human being. Conclusion, therefore, Socrates is mortal. Now, this argument also seems to be valid because if you assume the premise is to be true, then the conclusion must also be true. In fact, premise 1 and premise 2 are both true, actually, so the argument is sound. So we have two arguments, and both seem to be valid, but there is a crucial difference. What's the difference? Well, that is, the first one is not logically valid, while the second one is. Well, what does that mean? First argument, if you look at it, is valid because of what mammals and animals are. So, it's valid because of its subject matter. On the other hand, the validity of the second argument does not depend on who Socrates is, what a human being is, and what it is to be mortal. Its validity can be seen solely from the meaning of if-then. Okay, to see this point a bit more clearly, let's consider the following two arguments. Here we have argument 1, lions are mammals, so lions are animals. That's the argument that we had. And here we modify this like this. Argument 1 prime. Lions are mammals, so lions are omnivorous. Okay, here you can see that argument 1 prime, the argument on the right, is obtained by substituting omnivores for animals in argument 1. Now notice that argument 1 prime is not valid. Most mammals are omnivores, but lions are carnivores. So in the argument 1 prime, you have a true premise and false conclusion. Okay, so argument 1 prime is not valid. Now consider argument 2 again. Argument 2 is different from argument 1 in the sense that no matter what you substitute for Socrates, human being, or mortal, you will either get false premises or else true premises and true conclusion. So, no matter what you substitute for Socrates, human being, or mortal, you will always get a valid argument. You can see this point clearly by trying it yourself. So I would like you to pause for a moment and try to substitute some words, whatever you like, for human being, mortal, Socrates in this argument, and then see whether you can get true premises and false conclusion. What I'm saying is that no matter how you substitute these words, you will never get an argument with true premises and false conclusion. So from this, you can see that if you have an argument of this form, if x then y and x so y, then the argument is always valid regardless of what sentences you might have for x and y. And this is the distinctive feature of logical entailment. And this logical entailment is the subject matter of logic. Okay? And from now on, we shall use the term validity and entailment to mean logical validity and entailment, respectively. Now, from argument 2, I extracted a formative argument like this. So, Socrates' human being is now substituted by x on the right, and the sentence Socrates is mortal is substituted by y in the argument on the right. Okay? So these two have the same form, so to speak. In so doing, notice that I held if then part fixed and allowed everything else to vary. Okay? Those parts that we hold fixed in a given argument are called logical constants. So it remains constant, right, throughout. On the other hand, those parts that we allow to vary in a given argument are called variables. The meaning is that they can vary. You can substitute something else for it. So we can give a bit more precise definition of validity. An argument is valid when the conclusion must be true under the assumption that the premises are all true, regardless of how the variables are interpreted. An argument is invalid otherwise, meaning that an invalid argument is one in which you can interpret the variables in such a way that the premises are true while the conclusion is false. And those interpretations in which the premises are true and the conclusion is false is called counterexamples to the argument. So you can see here that the definition of validity corresponds quite well to the idea that an invalid argument is one with counterexamples. Okay. Now let's introduce the notion of sentential connectives. Now, in the argument, this Socrates argument, we took as a logical connective if then, and as variables the specific sentences such as Socrates is a human being and Socrates is mortal. So we held fixed if then part and let all these sentences vary. And we thus arrived at the argument format like this. Premise 1, if x then p. Premise 2, x. Conclusion, therefore y. Now notice here in premise 1 that the expression if then serves to connect statements like Socrates is a human being, Socrates is mortal. Those two sentences are connected by if then. So the logical constant, such as if then, is called sentential connective. So here we give the exhaustive list of sentential connectives that we'll be using in this course. Not this is called negation, and this is called conjunction, or this is called disjunction, and finally, if then, this is called conditional. The classical theory of truth functions is part of logic that studies the entailment relation that obtains in virtue of these four sentential connectives, or more precisely, in virtue of the behaviors of these four sentential connectives. And this is what we'll be studying this semester in this course. Okay, why symbols? Some of you asked this question. Now, recall that we want to study the entailment relation as determined by the behaviors of logical connectives. Okay? And to do so, it's more convenient and really practically necessary to use this kind of symbolic language to remove possible ambiguities and other unnecessary features of natural language. That way, we can represent the structure of argument in a clear and precise way. Okay? And that is the reason why we use symbols. You know, in the old days, people do arithmetic without the usual signs like plus signs, right? Time sign. They didn't have that. They were able to do arithmetic as we know it. However, it was much more cumbersome and difficult, right, to prove or to do calculations. It was a great improvement in the modern mathematics that we use the symbolic system. It improved clarity quite a bit. And the reason that we're using symbolic notation is basically the same. We want to gain clarity by using this language. We want to represent the necessary features that we're interested in a more perspicuous way. That is the reason why we have the symbolic language. Okay. So we shall use English letters like these capital letters, P, Q, R, and etc., sometimes A, T, as variables standing for sentences. And we'll use tilde, ampersand, wedge, and arrow as sentential operators, respectively standing for negation, conjunction, disjunction, and conditional. Now, a lot of you ask how to distinguish atomic from complex sentences. Well, the rule of thumb is this: any sentence that contains a sentential connective should be considered complex. I say the rule of thumb because, of course, there are counterexamples. So, the following sentences are complex. It's not raining. You can see a symbolization on the right. Okay. It's raining or snowing. Okay, so you see a straightforward symbolization on the right. R, wedge, S. Jack is home and Leah is at work. J, ampersand, L. I'll file a complaint if you do not help me on this. This is a threat, right? And you see a symbolization on the right. Not H, arrow C. I use parentheses to indicate the scope of the operator in the obvious ways. Okay. And so these are all the examples of complex sentences. And sentences that do not contain any sentential connective should be considered atomic. Right. So if you have a sentence, it's raining, that's an atomic sentence. Jack is home, that's also an atomic sentence. I'll file a complaint, that is an atomic sentence. But if you combine any of these using any of the sentential connectives, the resulting sentence will be complex. Okay. Of course, there are some exceptions to this rule, as given in the textbook. Alice and Bill drank a whole bottle of wine. Well, what's intended, right, in this sentence is that they together drank a whole bottle of wine, so it's not that Alice drank a whole bottle of wine and Bill also drank another, right, bottle of wine. It would be misleading to take the sentence Alice and Bill drank a whole bottle of wine as like this way, okay? They respectively drank a bottle of wine. That's a misleading way of taking it, okay? So there are some possible exceptions, but for the purpose of our course, right, this rule of thumb is quite sufficient, and you should use your intuitive understanding of English sentences, right, to come up with a proper symbolization. Okay, so there is no complete procedure that guarantees correct translations. We have to use our intuitive understanding of English sentences. Okay. Now, many of you asked questions about inclusive and exclusive use of or. Okay, in logic, it's standard, right, to use inclusive or. It's very rare to come across that takes exclusive or as primitive. And of course you might object to this, claiming that, look, when someone says, Jack is home, or Leah is at work, or any other disjunction, right? Or is more naturally taken in the exclusive sense, right? So what's meant by this sentence is that Jack is home or Leah is at work, but not both. That's the exclusive use of or. And you might think, in English, generally, or is used in its exclusive sense. And that is a reasonable attitude that you might have. Okay? And in logic, we could use or in the exclusive sense. That's a possibility. But I think it's a matter of like the historical development of logic that people decided to use inclusive or in standard logic. I'm not quite sure what's the rationale behind such decisions, but probably using the inclusive or was much more convenient in many ways. So, look, it's perfectly reasonable to think that in the ordinary English, or is used in its exclusive sense. However, for the purpose of logic, we shall use or in its inclusive sense. That's a decision that we make, and we shall just follow the standard usage in that respect. Okay. Now, there was some crucial error in Baruch logic. Or is symbolized with this bar symbol, not to wedge. In most textbooks, you'll find wedge symbol for disjunction or. But for the purpose of this course, you may use either one without any penalty. Just be aware that in Baruch logic, this bar is sometimes used to mean or. Okay? But the choice is up to you, and you will not be penalized for using bar instead of wedge or using wedge instead of bar. So the choice is up to you. But of course, you should not confuse bar with ampersand or bar with arrow and so on. Okay. Another set of questions concern if then and only if. Well, these are all about conditionals. Now, what exactly is the difference between if then and only if? It might be helpful to introduce some terminology here. Consider the following sentence. Okay. If a figure has exactly 3 sides, then it is a triangle. So if you want to symbolize this, you have it on the right. F arrow T. Okay. Now, what this says is that having exactly 3 sides is sufficient for something to be a triangle. In other words, any figure, as long as it has exactly 3 sides, is a triangle, right? So, in general, when you have a true conditional of the form, if P then Q, P is said to be a sufficient condition for Q. Okay. Now, compare that to this sentence. If you want to get an A for this course, you'll have to submit all the homework assignments. Okay, so here you have an example sentence. And this says, submitting all the homework assignments is necessary to get an A for the course. That is, you will not be able to get an A without submitting all the homework assignments. So in general, if you have a conditional of the form if P then Q, Q is said to be a necessary condition for P. So these are the converse of the others, right? If you have a conditional of the form if P then Q, P is said to be a sufficient condition for a Q, and conversely, Q is called a necessary condition for P. Okay, suppose now that you just signed a contract with Jack and you want to say that Jack needs to pay the rent first to get a key to the apartment. In other words, his paying the rent is a necessary condition to get a key to the apartment. Then how would you say it? Using if then. A natural way would be this. If Jack wants to get a key, he should first pay the rent. So you have a symbolization K arrow R. If Jack wants to get a key, K, then he should first pay the rent R. Right. But there is another way of saying this. Jack can get a key only if he pays the rent first. You should be able to see that these two mean the same. Now, so you see that the following two sentences are equivalent. If you want to get a key, then you have to pay the rent. K arrow R. Okay. And you get a key only if you pay the rent. K only if R. Since these two sentences are equivalent, in general, we do not introduce a new symbol for only if. Instead, we just translate K only if R into K arrow R in the symbolic language. And so, to summarize all this, we have this. K only if R says that R is a necessary condition for K. To say R is a necessary condition for K is to say if K, then R. So, K only if R is translated into K arrow R, which is a symbolization of if K, then R. Okay, so all you have to remember is that only if is used to indicate a necessary condition for something. Okay, and necessary conditions appear after arrows in general. Okay, and that's how you translate only if statements into symbolic language. Now, another batch of questions concern unless. The question is simple. How should we understand unless? Logically speaking. Now consider the following sentence. You'll receive a full refund unless your ticket was purchased as part of a vacation package. Okay, let's write it this way, R unless P. Okay, just, preliminary symbolization. We want to know how to translate unless into symbolic language. Now let's consider what exactly this sentence means. And if you think for a moment, you'll be able to see that the sentence above means this. If your ticket is not purchased as part of a vacation package, you'll receive a full refund. The only possible case that you may not be able to get a full refund is when your ticket is purchased as part of a vacation package. Right? So as long as your ticket is not purchased as part of a vacation package, you'll be able to receive a full refund. That's what unless means. Right? So, and you know how to translate this if-then statement. A straightforward translation would be this: not P, arrow R. Okay? And this means that R unless P means that not P is a sufficient condition for R. All right. Now, many of you ask, hey, how can I find the main operator of a given formula? Now, at first, it might seem quite difficult to find the main operator. And I think this is mainly because that you are just introduced to this new symbolic language, so you're not really familiar with it. However, if you get familiar with it enough, then it will not be so difficult actually to locate the main operator. So for now, I would like to suggest, do not worry too much about this. Instead, just play with it. Practice, do some practice translating natural language sentences into symbolic formulas. That way, you get familiar with this new artificial language, and after a certain point, locating the main operator of a given formula would not be a problem. So let's work together on some of exercises from homework assignments. Okay, consider this sentence. Either Sam is an actor and Patricia is a writer, or Robert is an actress and Tina is a producer. Okay, let's introduce, to simplify this sentence, let's introduce these letters to represent these long sentences. So we shall use S for Sam is an actor, we shall use P for Patricia is a writer, R for Robert is an actress, and T for Tina is a producer. Using these letters, you can simplify this long sentence to this: either S and P or R and T. Now notice that it begins with either, which corresponds to or in the middle. So you can see that either or, the disjunction, is the main operator in this. Okay, that is, the two occurrences of and in this sentence are both within the scope of either or. And so you can represent the structure of this sentence like this: S and P or R and T. Now, once you get this far, it should be very straightforward to translate finally into our symbolic language, and I'll leave that last maneuver to you. Okay, finally, let's consider how to translate this into the symbolic language. If Either Patricia is a writer and Quentin is a director, or Roberta is an actor and Sam is a writer, then Tina is a producer. Fairly long and complex, right? Now, but we can simplify it by introducing some letters for sentences. P for Patricia is a writer, Q, Quentin is a director, R, Roberta is an actress, S, Sam is a writer, T, Tina is a producer. Okay. Using these letters, my apologies, you can simplify the long sentence to this. If either P and Q or R and S, then T. Now notice that it begins with if, and this corresponds to then that occurs right before T at the very end. Right? So you can see that this part of the sentence, namely either P and Q or R and S, that part is within the scope of if then. So using parentheses, you can represent it like this. If, open parenthesis, either P and Q or R and S, close parenthesis, then T. Now look at the part wrapped in parentheses. It begins with either, and that corresponds to or in the middle. So within the parentheses, the two occurrences of end should be within the scope of either. So you should have if P and Q or R and S, then T. And you should finally introduce those symbols for and, or, and if then to finish up the translation into our symbolic language, and I'll leave that last maneuver to you. Okay, that's it for today. So I hope you get a clearer idea of what we'll be studying for the rest of the semester and see the importance of the symbolic language. Since we're going to use the symbolic language throughout the semester, it's absolutely essential that you get familiar with it. So please work on the homework and please let me know if you have any questions. Okay, thanks for watching and I'll see you in the next video. Have a good week.